Welcome, my friends. In this video, I'm going to be talking about the first section of the first chapter of Grand Valley's Stat 215 textbook. The first chapter is called Basic Terms, and the first section is called Data and its Role in Statistics. Now, the textbook doesn't actually start with a definition of statistics, but I think that's kind of important, so that's actually where I'm going to start. The definition of statistics that I'm going to be using here is the study of how to gather, organize, analyze, and interpret data. Now, there are three kind of areas here, and I'm going to talk about each of those individually. So first, we have the gathering of data. Before we can organize, analyze, and interpret the data, we have to gather that data in some way, which is usually thought of as being the realm of sampling and experiments. Once we have gathered the data, we may want to organize that data in some way, which is usually lumped into the category which we call descriptive statistics, or describing your information or your data. This includes things like creating charts and graphs to summarize your data, as well as other types of numerical summaries, like calculating an average or a standard deviation or other things like that to summarize your data. Finally, we have the last and perhaps the largest area of statistics, which is analyzing and interpreting data, what we typically call inferential statistics, coming from the word inference to draw a conclusion. This is when we use data from a smaller group, which we call a sample, to make conclusions about a bigger group, which we call a population. The two most common areas of inferential statistics are what we call confidence intervals and hypothesis testing. If anyone asks you what the two main areas of statistics are, you should say these last two areas: descriptive statistics and inferential statistics. Yes, gathering the data is important, but usually these last two areas are considered to be the major areas of statistics. Throughout this entire book, we're going to be talking about all three of these areas, and basically every chapter that we cover will relate in some way to one of these three things. Now, at this point, we haven't really given a definition of data, so let's go ahead and dive into that a little bit deeper. So we have to make the differentiation between raw data and just data. So what do we mean by raw data? Well, the definition that we're giving for raw data is information that has been collected but not processed in any way. And this can take a lot of different possible forms. This could be information that's somehow, given by a computer that's, been reported through the logs, or maybe you've given some kind of survey and you have those results either on paper or maybe in a spreadsheet. There could be all kinds of different ways that you could have raw data. But the key here is that it hasn't really been cleaned up or organized really in any way. We just kind of collected this data and we have this data, and we'll call that raw data. And when we talk about just data, not raw data, but just data, we're going to consider that in this class to be raw data that has now been cleaned up so that it can be analyzed. So this could include a number of different things, such as maybe kind of eliminating some of maybe the mistakes that are in the recording of the data, or putting it into a table form so it's easier to analyze. There could be a number of different things that could go from changing the raw data into data. So let me just give you an example of that. Here's an example of raw data that's actually already relatively organized, but just has a couple of mistakes or a couple of things that might need to be fixed or cleaned up here. So this is a snippet from a data set that I gathered from my students in Stat 215 class. And one of the variables that they were asked about was how many people that they live with. And you can see a couple different answers that were given here. Maybe one person said they were living with 4 other people. Another person said 5. But then we have this person here who said that they live by themselves. But really what we're trying to get at here is we probably need numbers in this data set. It might cause an issue if some of the answers here are words. So maybe instead of having live by myself, I would want to change that to a 0. So maybe that would be an error or something that would have to be cleaned up in terms of this raw data. And we have the same kind of issues with these other two variables. We have the GVGPA, which would be the Grand Valley GPA, and someone just said around 3.8. Well, we're probably going to want to change that to just 3.8. Or student loan. Someone just said, oh, I'm not going to have any student loans. They said none. But maybe we need that to be a 0. So maybe to clean up this data, we might make some of those changes, right? So now instead of live by myself, we got 0. Instead of around 3.8, we have just 3.8. Instead of none, now we have $0. This is a very kind of simple example of how you might go about cleaning some raw data. Once again, I'm saying this is actually probably already in a lot better form than a lot of raw data will come in. But this is just a simple example of how you may clean up raw data so that it can be analyzed. And again, it looks like I'm emphasizing here that the raw data might not even come in the form of a table. So it could be even messier than what I am displaying here. Okay, so we have a couple of other terms that we need to kind of get out of the way here. So in statistics, the individuals are going to be the objects or people that we are collecting data from. They don't have to be people. They can be a number of different things. They could be animals. They could be tables. It could be objects, right? Whatever you are actually collecting the data from, that's what we would consider to be an individual. And a variable is a characteristic that can be collected from an individual. So maybe my individual is a Grand Valley Stat 215 student. And a variable I could collect would be maybe their GPA, or maybe their age, or maybe their major, right? Or maybe a different individual, maybe I'm considering is like a house, right? Maybe I'm kind of looking for a house, and maybe a variable I could collect from a house could be the price of the house, or maybe the square foot of the house, right? So it doesn't really have to always be a person in terms of an individual in statistics. It can be some sort of object, or really whatever you're studying and collecting data from. Now, an observation is going to include all of the variable measurements for a single individual. So if my very first individual's name was Sam and he was a Grand Valley student, then the observation would be all the variables that I had collected from Sam, maybe his GPA, his major, etc., right? So an observation is basically just going to include all the variable measurements for that individual. Okay, so here's an example here. So this table below is from the Grand Valley textbook here, and it shows the structural health of 5 different Michigan bridges. So we have all of these kind of different variables, which are represented basically by in the very first row here, and then we have a number of different bridges. So we have the bridge, I guess like the number, the county, the route, NHS. Maybe it's not really clear what that means. I'll reveal that in a second. We have age, inspection, deficient, and obsolete. So a lot of times in these data sets, sometimes the labels for the variables are not always super clear exactly what they mean. The example here is the NHS. What does that actually mean, right? So sometimes there will be what's called a data dictionary somewhere else that will kind of describe what these variables are. We kind of want to have like a shorthand way to refer to the variables in a data set, which is why we have just like the single words here, but maybe somewhere else they'll be described in more detail. Okay, so let's answer a couple of different questions here. So what is an individual? Well, typically if you have a data set in this form, typically an individual is going to be represented by each row of the data set. So in here, each one of these rows is representing a bridge, which is the information that we're collecting from a bridge, right? We have the bridge number, the county, etc., right? So each row relates to a bridge. So the individual here is just going to be a bridge. Second, what are the variables? Well, the variables are basically everything that's given in the very first row. We have bridge, county, route, NHS, age, inspection, deficient, and obsolete. And then maybe we're asked to describe the first observation. So remember, observation just refers to all of the variable observations or the variable details for one individual, right? So the first observation would be everything in this second row here, which relates to bridge number 1. And so here's me kind of describing that. So the first observation relates to a bridge B1, which is in Alcona County on US 223. The bridge is part of the National Highway System. So that's what the NHS stands for, if you weren't sure. It's the National Highway System. It's 77 years old, and I guess I missed the inspection here. It was last inspected on September 22nd, 2010, and it's not deficient or obsolete. So that's just some kind of basic information about how you would read some of these tables and identify some of these important terms. Here's another example. So we have a data set that has students, their GPAs, their class standing, their current grade, and their major, right? So what we call like a properly structured data set, or maybe a clean data set, sometimes it's called that way, is typically going to be kind of organized in this sort of way, where each row is going to contain data for a single individual, or you could say each row is an observation. So the very first row, all the stuff in this row here relates to Laura Mifflin, or all the stuff in the second row relates to Maxwell Jones, his GPA, class standing, etc., right? So if it's a properly structured data set, which is what we're typically going to have in this class, you're going to expect each row to represent data for an individual. On the other hand, each column should contain data for one variable. So everyone's GPA is in this column, or everyone's class standing is in this column. So if we go down the column, we know we have that variable for every single individual. So typically we're going to have our data sets structured in that way as well. Now this last one is kind of hit or miss. This is ideally what you would have, but sometimes this might not necessarily be there. But the first column should uniquely identify each individual. So we know that this row relates to this unique individual, Laura Mifflin or Maxwell Jones, etc., right? And sometimes this will be done by means of some kind of like ID number or something to make sure it's unique, just in case there were repeats. But ideally, you would also have the first column uniquely identify each individual. Okay, the next thing we want to talk about is the difference between data and anecdotes. So you probably have an idea of the difference between those here, but let's make the differentiation. So an anecdote is just a story or an example from a single individual. So here is an example of that that's given in the textbook. So the Grand Valley professor who wrote most of the textbook is John Gabrosik, and his grandmother lived until age 97, but she ate bacon cooked in butter, I think he said, practically every day. So here is a picture of his grandmother. And I really like the quote or the text that he gives in the book, so I'm actually going to read that here really quick. He says, referring to his grandma, that, considering she lived to 97, does that mean that we should all just eat bacon cooked in butter every single day to live long? Well, it's delicious, but it probably won't help us live to age 97. Gabrosik's grandmother might just be an isolated case. She provides anecdotal evidence for eating lots of bacon cooked in butter. A dietary decision should not be one that's based on one person. Anecdotes are only interesting when they are exceptional, which is the case here, right? It's because his grandmother ate so much bacon and lived to be so long that the story is even interesting or worth reporting on in the first place. So we remember the exceptional and tend to forget the typical. So this is an exceptional story, which makes us kind of focus on it. But what you should not come away from this is that we should all just do this, right? We should all just eat bacon cooked in butter. That would be the kind of story you'd come out with from just looking at the anecdote. But really what we should be focusing on in most cases, and what statistics is based on, is data, which is instead of just focusing on one individual, we should collect information from many individuals, ideally gathered using some kind of random method like a random sample or experiment, and then focus on that information or that data to really make our decisions or draw our conclusions. So what does the data say about eating bacon cooked in butter? Well, we know from a large body of evidence, which we would call data, that high amounts of saturated fat, as present in bacon, can lead to several forms of heart disease if consumed too frequently. In fact, maybe you do or do not know this, but all processed meats, including bacon, are actually classified as carcinogenic by the World Health Organization. So definitely this is not a great idea to consistently be eating processed meat or especially bacon on a regular basis if your goal is to live to a longer age. This is an exceptional story that is not actually typical. So using data is going to help us focus more on what is typical than what is exceptional. And it's going to be a more objective way for us to form beliefs and make decisions about the world. And like I already said, this is the way that this class is going to be organized. It's all going to be related to data and not based on anecdotes. All right, so here we have kind of a question for you to try. So we'll typically have these throughout the videos here. So this says, for each of the following situations, describe the individuals under study. That is, who or what are we collecting the data from? So we have two different parts here. So I'll let you go ahead and read through those. And this is kind of the universal symbol here when we have the 3 question marks, that this is a question that you're going to need to answer as part of a quiz on Blackboard if you were one of my students. So you'll need to go into the Blackboard quiz related to this question or this chapter, and you will have to answer this question here. It's going to be the second question, but please go ahead and try both of these questions to see if you can get an answer. All right, that's all I have for this video. I will see you in the next one.